Jake's total willingness to pay for Burrito Brothers burritos is given by V equals 6 times the square root of Q. Jake's inverse demand for burritos is blank. Well, we know given a total value function, to find inverse demand, we just need to take the derivative of that value function with respect to Q. So when we take the derivative, we find that price is equal to 3Q raised to the negative 0.5. And let's talk about that derivative real fast. We multiply the exponent by the coefficient, 6 times 0.5 to get 3, and we subtract 1 from the exponent on Q. So it went from Q to the 0.5, and then we minus that 1 to get Q to the negative 0.5. Refer to the previous question. If the marginal cost of a burrito is constant at $2, all customers were just like Jake, and fractional burritos are not possible, the block price for the profit maximizing bundle of burritos to package together would be blank. So we need to solve for the block price. First, let's look at a linear example to help us organize our thoughts. In block pricing, we want to extrapolate all of the consumer surplus and cover all our cost. So we want to produce at Q star units, and then we want to charge a single price equal to this whole blue area. So first, to find Q star, we need to set inverse demand equal to marginal cost. In our case, inverse demand is P equals 3Q to the negative 0.5, and marginal cost is $2. When we set these two equal, we can do a little bit of algebra and solve. First, let's rearrange this to where the negative exponent is on the bottom of the fraction, and then cross multiply to get that out of the denominator. Now, dividing everything through by 2, we find that the square root of Q is equal to 3/2. So we can square both sides to get rid of the square root of Q. And when we do this, we find that quantity is equal to 2.25. Remember, we cannot have fractional burritos, so we need to round to the nearest whole number. In this case, 2.25 rounds to 2. So now that we know that we want to produce 2 units, we remember that we're not dealing with a linear inverse demand curve, but we can still use the same method to solve. We need to find the block price by plugging in 2 units to our total value function, because that's going to give us, remember, that whole blue area shown in the graph. So, starting from our total value function of 6 times the square root of Q, we plug in 2 units, and we find that our block price, in this case, is equal to $8.48.